Hello, we are Team 1, and we have all of our members here. We are discussing for our discussion post from last week, our play and apply questions. I'm Emily White. Here we go. So my first question was, it was number 3 from the play section of 2.7 on the exercise sheet. And the question had 3 parts, and I was mainly confused on part 3, because so I guess I can just write out the question first. I'll write that out. I was writing.
Oh, okay.
Okay.
Wait, so this is chapter 2?
This is 2.7.
Oh, okay, so we can't use the differentiation rules.
No, this is question 3. So find the slope of the tangent line to the parabola at y equals f4x minus x squared at 0.13. So
Okay.
I started with the fx minus fa over x minus a limit formula. And then I plugged in 1 for the x, or I plugged in 1 for a, sorry. So it ends up being limit as x approaches 1 of f of x minus f of 1 over x minus 1. And then I plugged in what the actual formula would be, which became limit as x approaches 1 of 4x minus x squared minus 4 times 1 minus 1 squared over x minus 1. And obviously that just simplifies down to x minus 1 and 3 minus x. And then over x minus 1. And then those cancel out. And you end up with, limit of x approaches 1. Then you end up with limit as x approaches 1 of 3 minus x equals, plug back in with direct substitution, the 1, 3 minus 1, and you get 2. So that's the slope of the tangent line using the using definition 1. And then I just did the same thing using equation 2 for part II. So with using equation 2, it's just m as limit approaches n approaches 0. Or h approaches 0, sorry. F of a plus h minus f of a all over h, and we do direct substitution, and we get limit as h approaches 0 of f1 plus h minus f of 1 over h, and then you have to plug everything into that. So to figure out what f of 1 plus h is, I just did that separately. So that would be 4, 1 plus h minus 1 plus h squared, and that becomes 4 plus 4h minus 1 plus 2h squared, or plus h squared, and then that becomes 4 plus 4h minus 1 minus 2h minus h. That simplifies down to 3 plus 2h minus h squared. And then I did the same thing just separately for f of 1. So f of 1 is is going to be just simply plugged in as 4, 1. Nope. 4, 1 minus 1 squared, which becomes 4 minus 1, which is 3. So then I went ahead and just plugged both of these in their respective places. So it became, can you see if I move over here? And move over here, okay. So then just plugging those in, it's m as limit of h approaches 0, and you get 3 plus 2h minus h squared minus 3 all over h. And then you get limit as h approaches 0 of 2h minus h squared, I think. I can't read my handwriting. Over h. And h2h. Alright. h2 minus h over h simplifies down to limit as h approaches 0 of 2 minus h. Your h's cancel out up here, and you get m equals 2. So I got 2 for both of the answers, which made me think I did it right because I got the same slope with both ways. So that was fine. And then I had to find the equation of the tangent line, and I guess I was just confused on if we were using the y minus y1.
Yeah, that's what we
Is
use.
that what we would use? Okay, so then let me just erase this part and write it out. So then it would be y minus y1, which we decided was, what was it?
It was 3.
3. And then our slope was 2, x minus 1.
Yep.
Okay, so then is that our formula?
Put the x minus 1 in parentheses, but yeah.
Okay, so that was all I was confused on, and you guys answered that in the discussion. So does anybody have any comments?
I was confused in like something you were doing in the discussion, but now it makes sense, so
Okay.
I think I'm good.
Yeah, I think you were confused on why I was just putting f of 1, but I was going back and substituting it in. So I was just, when I wrote f of a, I just wrote in f of 1, and then I went down here and calculated f of 1 instead of just plugging that directly into there. I think that's what you might have been confused on.
Yeah, I had the same issue.
Yeah.
I suppose.
Yeah.
Because, yeah, I just wrote f of 1, and then I
I
went
was
in and
always-
actually did the 4.
Right. I was always confused on that first definition of the derivative.
Yeah.
Like when we first learned it, for whatever reason.
Yeah,
It confused me, but because, yeah, it doesn't matter.
yeah, I just factored it out, and then it
Yeah.
all worked out.
As for the second one, I think it makes sense to an extent.
Yeah.
It's just the ones that confused me a bit.
Yeah, and it's a long problem to work out. There's just a lot of like simplifying down, so it looks really complex, I guess, but it's not. It's just a lot of direct substitution. Okay, anything else?
So the first one is definition 1,
Yeah, this is definition 1.
the A.
And then where you do the f of x minus f of a over x minus a. And this was equation, I think she had it labeled equation 2.
Definition 2, yeah.
She had it like as definition 1, equation 2 in the homework, or the textbook had it as definition 1 and equation 2.
I think it's like the same category, though.
Yeah, which I think we in class just referred to them as definition 1, definition 2.
Okay.
But in the textbook they call it equation 2.
So, when would you use one over the other?
Oh,
Did
geez.
you tell us to always use the...
Yeah,
Second one?
I think she said I thought the H.
I think you can use both, but like
Yeah.
I think there are some instances where you just can't use the X one, and you have to use the A one.
Yeah.
I think maybe it's when you, because like if you don't have a point for f of a,
Yeah.
then you have to use the equation too, because then you have to find the derivative of the equation, and then you can like plug in variables or whatever. But
Yeah.
if you're given an actual point, then you can do fx minus fa.
Yeah. Okay, I'll go ahead and write out my second, my apply problem, and then we'll be done. So this was my apply question. It was from 2.7 again. It was number 48. And it was the number of bacteria after T hours in a controlled lab experiment is N equals F of T. So then it was, what's the meaning of the derivative F prime of 5 and what's its units? So that's the part that I was confused on. So I knew that 5 had to stand for hours. That number meant hours. And then I was confused on what the derivative means other than that, but I think we talked about it more in class, and I remembered that it's the rate of change. So it's the rate of change of the bacteria, number of bacteria after 5 hours. It's basically what it is, and Dylan helped with that one in the discussion thread. So it would be rate of change of number of bacteria at 5 hours. And then the part B to that was supposing unlimited nutrients in space, which would be larger, F prime of 5 or F prime of 10. It would be F prime of 10 at unlimited nutrients because it was growing in a positive way. So it would just keep increasing as the hours went on. If the nutrients were limited, it would depend how the nutrients were limited, I think. If it reached its limit before getting to 10 hours, then 5 might be bigger. 5 might be the larger number because they may start to die off before 10 hours. And that's...
Well, it's the rate of change.
Yeah.
So if they couldn't reach 10 hours, then it would guarantee be bigger.
Yeah.
Because there would be no growth whatsoever, you know.
Yeah. It would stop growing because they'd stop growing. There'd be less of them.
Right.
So yeah, that was that one. Does anybody have any comments? Did that make any sense at all? Do I need to explain it again?
I get it.
Sense.
Okay.
Can you explain part B for me?
Okay, so what they're asking is if in the lab experiment you had unlimited nutrients in space for the bacteria to keep growing, then at each hour it would keep increasing, like the amount of them would keep increasing. So at 5 hours, say that maybe it was increasing by like 5 bacteria at 5 hours, let's say. And then maybe at 10, if there were unlimited space, you had unlimited nutrients, it would just keep increasing. So then by then there might be increasing by 20 at 10 hours. 20 at that exact moment, the rate of change might be 20 more bacteria. Does that make sense?
Yeah.
So that's with unlimited space and nutrients. So I think F of 10 would be bigger. But if there were a limited nutrient supply, then as the hours went on, they would not have enough nutrients to keep multiplying. So there would be less of them, and the rate of change wouldn't be increasing as much each hour. Does that make sense?
Yeah.
Like
So
it would, if it was a graph, it'd flatten off.
yeah,
at
it would
one point.
plateau. So if we were doing this, it would be like, if we were, say we were growing steadily, which I doubt we would be with the bacteria, but say that we're growing steadily, then all of a sudden it, we start to hit our nutrient limit, then it would start to flatten out until it was completely horizontal. Does that make
Right.
sense?
I think in this case it would be an exponential.
Yeah, it would probably be an exponential, so it would probably be like that, but does that make sense?
Yeah.
Okay, awesome.
Because like bacteria reproduce presumably, and so maybe you start with like 5 and they're going to double, they're going to become 10 and then 20 and then 40 and then,
Yeah.
you know what I mean? And so they need nutrients and space in order to keep multiplying. But if they run out of the nutrients in space, say that they reach the end of the petri dish, then they can't grow anymore.
Yeah.
Now that I think of it, some bacteria have medical purposes, like penicillin.
Yes, penicillin would have that issue. Yeah, there's a lot of things. You could also apply it to like macrobiology, like if you try to think of an ecosystem similarly instead of like microbiology with bacteria, you could think of like if there were, say, a bunch of bears in a population and they were growing because they kept having babies every season, right? There were baby bears appearing every season. There were more of them every season, right?
Yeah.
But then say that they ate all the deer because they ran out of nutrients, which are the deer, then they wouldn't be able to keep having baby bears because they would be weak. And so the population, and some of them would die, so the population wouldn't be increasing as much each time.
Mm-hmm.
Does that make sense?
Mm-hmm. Yeah.
Baby bears. Okay, well, thank you for your time.
I think I'll go next.
Okay, awesome.
Hello, my name is Christian from Team 1, and my play, I'll be doing training 7 on 2.6 of the exercise worksheet. Would be a limit of, it should be the limit of as x approaches to infinity. And why am I keep messing up my words?
You're good. If you want to write the problem out and then start explaining, you can do that too.
Mm-hmm. Actually, playing my left hand would be much easier. X plus AX and ugh. Plus BX. So yeah, the pawns I'll be the play pawn I'll be doing today would be as the limit of x approach to infinity. The square root of x squared plus ax minus the square root of x squared plus bx. My question for this particular problem is there any other way to solve this other than the quadratic formula?
Okay, so you use the quadratic formula to solve it?
Mm-hmm.
Okay.
Yeah, but is there any other way to solve this problem without using the quadratic formula?
Well, let's see the quadratic formula solution, and then maybe it'd be easier to answer that. Because you could do direct substitution immediately, and then you would just get 0. So you need to change it.
So yeah, what I did is use the quadratic formula to solve it, and ooh, that didn't turn out right.
It's okay.
How did you solve it with the quadratic equation if it's only variables?
Wait, so you can't just plug in infinity here, right?
No.
Yeah, that's the
Because
problem.
infinity minus infinity is like a problem or something.
Yeah.
Okay.
Yeah, try to substitute infinity in there, and you're just going to end up with a headache.
Yeah. It will just, I think it will get you an indeterminate form.
Plus, chances are, it might make you go insane.
That is true. Math will do that to you.
Wow.
And
How does this work? I wanted to look at it up close.
So is that the what's the word? Where you do the other square root?
Yeah,
Something with an I.
inverse.
Okay, and the quadratic, isn't it like negative b plus or minus square root of 2
Yeah.
or whatever?
Yeah.
Wait, but where's the negative b?
And then,
Are you sure the quadratic is what you used, Christian?
honestly, I don't
You don't remember the name of it? That's okay.
know, but
Why don't you just work it out and then we'll see if there's another way to do it.
yeah.
Okay.
Basically, I need someone to fact check me on this.
Yeah, no problem.
It's like he's multiplying by the reciprocal.
Yeah, I think that's reciprocal.
That's what he said.
Starts with an I.
Okay, we got 2 questions. My first question is, what kind of equation that I use? And second one, is there any other way to solve without doing this?
Yeah, I think either way you have to do it the long way. I don't think there's any way to shorten what you did. Just looking at your work, it looks right.
Yeah, I feel like my arm's about to fall off at that point.
Yeah.
Hmm.
Yeah.
Yeah, this problem is
It's a lot of variables.
yeah. Like you could try to foil.
But,
You okay?
again, I feel like my left arm's about to fall off.
Do you need me to hold your surface for you?
Yeah, that would be great.
Alright.
Holding 2 things up. Holding 2 things at once isn't easy.
No, it's not.
It really isn't.
the step you just did, the
Yeah,
a minus b times x over
yeah. At that point,
x. How'd you do that?
in all honesty,
How'd you go from the numerator before to the numerator you just wrote? How'd you do that?
in all honesty,
Don't remember.
Yeah, but looking at it, like, did
hold on, let
you
me.
foil or? No, you couldn't have. Maybe you could have.
It looks like he foiled.
Yeah, because then he'd get ax, a
Yeah.
squared, or he'd get x squared plus bx.
It
Wait,
looks like,
what?
it looks like I moved the X and foiled. I think.
Okay.
I mean, I'm literally trying to put the pieces together on this one.
Yeah. Did you go to the tutoring center for this one, or how did you work this one out? Did you just do it at home?
I did it at home.
Okay. Yeah.
So again, I need someone to fact check me on this.
Yeah, of course. Because sometimes I went to the tutoring center and they worked a problem out in a way that we had not worked it out, and I think they used the power rule or something when I was using the definition, and then I got really confused when I looked back at my work. But that might be the same thing that happened here. I don't know.
Yeah.
Yeah, he foiled.
Okay. So yeah, you just foiled that out.
And it reduced to that?
You just skipped your work for reducing it. It's okay. You're good.
Yeah. You may need to help me fix that place later.
Yeah. No, you're totally good. And you did everything right. It's
Mhm.
just I think the work was a little bit confusing to follow, but you did it right.
And then I think
Okay, A minus B, then
Sorry.
then this gigantic mess.
Yeah. This whole problem's a big gigantic mess.
Let's hope the instructor doesn't put this as. I don't think I can take this anymore.
You can do it. I believe in you.
I'm
You
in
did,
full-
you did it once. You can do it again.
I'm in for physically learning this on a whiteboard and mentally.
Yeah.
Because I don't want to see this type of problem.
You don't see it. We might see something like this on the exam, but we'll get through it.
Thanks. Okay, let me see if I've done this right. If we make A and B zeros,
Mm-hmm. You need A minus B over 2.
and it would be A minus. It would be something like this.
Yeah.
So it's A make this, well, not short, but less confusing as possible.
I think the only thing that would make it a little less confusing if you were looking back on your work is right here. You did FOIL and simplify, so I think if you wrote out more of the steps for that, it would be a little less confusing. So it would be limit as x approaches infinity of x squared plus ax minus x squared plus bx over.
Give myself the parentheses there.
Oh, did I? Sorry. Where is the parentheses supposed to be?
Mainly over there. Saying
Oh.
you did that probably.
Oh, okay. I got you. Like that?
Honestly, I don't know why I did that over there.
Okay. So like that?
Yep.
Okay. So then it would be x squared plus ax plus x squared plus bx. Right? And then you just FOILed it out, right? So first, right? So x squared times x squared would be 2x squared, right?
Mhm.
Okay. Outsides, those would be these two. So it would be bx. What would-
Wait, I'm forgetting the.
You're just multiplying for FOIL.
Ah.
So it would be x squared times bx would be
it's either bx cubed or x squared bx.
x squared.
I just don't know if they can combine like that.
Yeah, I don't know either. That's what I'm wondering. I don't know if it's bx cubed.
At this point,
Isn't x squared times x squared x to the fourth?
It would be bx times x squared. So it would be bx cubed.
No, like x squared times x squared. Isn't that x to the fourth?
Oh,
Yeah.
yeah. Sorry.
Yeah,
Never
and-
mind. My bad.
and
I think you can do bx cubed, yeah.
Okay, so
and
bx,
this one would just be back to the third.
bx cubed. And then we
Same
do
thing with this one, except for the A.
ax cubed. And then inside, outside, last. So it would be abx squared. Right?
And then you gotta include the minus in there
Yeah.
somewhere.
Make that a plus, make that a plus, make that a minus.
Make that one a minus as well.
Mm-hmm.
Okay. And then you can go ahead and simplify that down to, how would you simplify that down? I'm bad at FOIL. Does anybody else want to come up and try it?
Well, you did the foiling. It's just the simplifying part.
Yeah. So if you click on the keyboard, it should show up.
I mean, there's nothing.
We're
Just
still
pull out
recording.
x's. So just pull out x squared.
Yeah, just pull x squared out with the entire situation.
Yeah,
X
so
squared.
do x squared plus bx minus ax minus a, or ab or whatever.
Squared plus bx minus ax minus ab.
Is this all in the numerator or?
This is all in the numerator. We're still just doing the numerator.
Okay, then I think you just leave it like that.
Okay. And then in the denominator, we can go ahead and simplify that out too and FOIL it. Want to try foiling it?
What do you mean foil?
I don't know.
You're adding them.
Are we adding them?
Yeah.
Oh, okay.
Oh, now I see how to do this. This have to go to the denominator as a negative x squared, or x to the negative power of negative 2.
Yeah.
Then do this.
Okay.
So essentially, it'll look something like this.
Okay.
I mean, leave those to be
Mm-hmm.
for now. Then, if we turn that into, put that there, it has to be a negative, if I remember correctly. That way, wait, no, that one.
Yeah, I'm still confused on how
Wait a
we
minute,
got
wait a
from
minute.
this to this.
Wait a minute. Why not make it a negative x?
What are you trying to do?
Are we still trying to? We're still trying to show how he got from
From
this.
here to here.
Yeah.
But he was like talking about x negative x to
Yeah,
the
I'm
power
trying to-
negative 2.
Well, because we had x squared up here. We factored it out, right? So now I think he's trying to get it into the denominator.
Well, you can't just move it like that.
Is
You
that what
have
you're trying to do?
Yeah, but how do I do that without actually buying it? Well, make it look, suspect.
Yeah, no, I get what you're trying to say. I'm still not sure how we got this up here.
Yeah, they got like brackets and stuff.
Yeah.
Yeah.
Do you know how you got that?
It
I
is.
don't have my worksheet with me. Does anybody have this one already worked
Well-
out on their laptop?
I didn't touch this one.
Okay.
I didn't either. I mean, I can do it.
Yeah,
Is
I'm just
that-
thinking maybe if we start over from scratch, we might be able to see where he went. Don't erase it. Just
Yeah.
if we start from scratch, we might be able to see where he got what he got.
Yeah.
Is that a /x on the?
Is that /x or 1x?
I think that's supposed to be 1x, I
1x.
think. But I don't know.
Okay. Yeah, because you can't have
Or
if
may-
it's /x, you can't have it already in the.
Yeah, I kind of just like. Well, no, I got the text back at home.
Yeah.
So when I'm trying to solve that, it gave me something like, I don't think I did this right.
That's okay. We'll figure it out. Cause yeah, I don't even know that you need to do FOIL up here. Now that I'm looking at it.
Yeah, I appreciate that. Just makes it redundant.
Yeah.
Point.
Okay. So yeah, erase that. We'll
But
work
let's try.
something out.
Yeah, let's try a different approach to that part.
Yeah. Sorry, I'm just gonna scoot past you.
I think we should try a different approach for that.
Yeah, we're gonna try working it out from scratch again.
Is this a radical x to the second x squared?
Yeah, I think so.
Is that
Yeah, I think so. But
so? Just
Yeah, that'll be an X. Again, I try my best to wrap my head about what I just did,
No, you did great work explaining what you thought you did.
but at least I do know that giving me those two. But what I do know is that this gives out this X.
So you started with
Yeah,
doing the rad. What is it? Rad. The word you said.
The reciprocal.
Reciprocal.
Is that what the word you're looking for?
Yes.
Okay.
Reciprocal. You started with that here, right? And you divided by the reciprocal, and
yeah. Yeah, that's exactly what I did. No. Now that I think about it, by pulling them out, I got rid of the radicals. Don't know why I put that there.
I think what we were trying to do earlier is we were trying to like foil this out,
Mm-hmm.
but we can't do that because
The
there's
X
a
is a
minus here.
negative. I realized that halfway through. We have I thought it was a negative in front of the X, but it's negative between them.
Okay, so we have to like get rid of this bottom part here. I don't really know how to do that. I guess we could like move everything up. We could just put this holding parentheses and just put like a -1, but that probably wouldn't do anything. We can try to just square everything.
Oh, I attempted to move the X.
Like we could literally just square everything.
You know,
Is that even allowed?
Yeah.
Yeah, that's allowed.
now that you think of it, is that even allowed?
as long as you do it to both,
Top and the bottom.
yeah.
Yeah,
Okay. Well,
that could work.
I'm willing to attempt that. So then it's x squared plus ax plus squared plus bx. That's the denominator, and then this is going to be. I gotta put all that out. Wait. Oh, I don't even need to foil that out, do I?
We still need to deal with that negative.
I still need to deal with that negative. That's
Well,
right.
I could think of two ways to do this.
Well, I was thinking, okay.
You foil that negative bin, and try getting rid of that. Get rid of it that way, then foil. Or do it with a massive headache.
Yeah, I'm just trying to see if maybe.
Okay, I think I come up with two options here.
I still don't know.
Oh wait, I think I come up with
how
two
he
options
cut
here.
This.
Uh,
He did the reciprocal, but
Yeah,
Um.
I'm trying to find the original. response.
Oh wait, I think I come up with a solution for this one. Well, with this particular problem. If I find the negative like so, wait, I really messed that up.
This is number 27.
Yeah.
Okay. So
this is just like hard algebra, I guess.
If I find a negative then, you should see some things canceling out. Hopefully. Essentially, these get cancelled out. Negative x1 may result in this. that won't make any sense.
I actually just don't know how to do it.
I'm trying to Google this question just to try and figure out where we are.
Whoops! I think I missed one point.
That's okay.
Like, I feel like squaring it isn't how we should do it.
Yeah.
So
It's like, cause we can't do direct substitution here.
And we don't know what would happen if both the negative into this particular problem, this particular section.
What?
Like, I tried pulling this negative into this, and
So you need to rationalize by multiplying by the conjugate, and then simplify the numerator, and then factor x out of the denominator and reduce the whole fraction, and then take the limit of the whole expression, like this. At least that's what the internet says.
now I see what that. Now I see what that came from.
Doesn't make any sense. They show the steps down here, and they talk about it up here.
So they're just multiplying by the reciprocal,
So yeah.
and then they have the x squared plus ax
Oh.
minus.
Oh, now I see where that came from.
Why do they have a, b, c?
Oh, wait,
so
now-
they just pulled x out of everything?
Yeah.
Oh, okay, now I see where that came from.
Okay, and then
Oh, I think I'm starting to see where that came from.
Okay.
you can pull out x out of the radical there. I didn't know that. Okay, and so they
Oh.
didn't put parentheses here either, which is super weird.
Oh, wait.
Yeah.
Oh, wait,
don't
I
know
think I
if
did
that's
this wrong.
allowed.
Wait, now I know what went wrong in this.
Sorry.
Sorry, you guys. They also show it this way. I don't know if that
Like
changes anything.
most of the time you're supposed to put it in the parentheses, no?
Yeah, but I'm not sure that it matters because you can still just take x out of it.
I guess so, yeah.
Right?
Yeah. Just take x out. I guess.
I guess.
I think x plus a.
Oh,
Wait, this is so weird.
Oh, wait, I think I know what it's asking. Oh, wait, I think I know what it's asking. I mean, that 2 squared and this 2 squared canceled out. Then remove the x from the entire thing, giving you this.
Lost.
Take a look.
It's weird that it's minus there. Why is it x squared minus bx?
It's because you need to force that negative into this part.
Into both parts? Okay, that makes
Yeah.
sense.
Then,
Okay, so all they did was they got rid of the parentheses by just like distributing the
Mhm.
minus sign.
Okay. That makes sense.
Then since it will result in these two x go canceling out.
Oh, then the x squares cancel out. Okay. You got
Oh,
it,
yeah, x
bro.
squared minus x squared.
Mm-hmm.
And then you can just
Okay.
factor x out of a minus ax minus bx. Yay! So that's how you got to where you got over here.
Yep.
Okay. So this section was you just factored.
God, this is so weird.
As with this part.
And then on the bottom they have 1 plus a.
Oh, now I see it.
1 plus
the
a
x
divided
over.
by x. Like,
No, we
what
put
the
x
hell?
over here. Yeah.
Where are they getting 1 plus a divided by x?
But then what do you do with this?
Then you take. They explain their steps
Oh, wait.
down here.
Oh wait, now see what they did there.
Explain there.
Oh, wait.
Yeah, but
Wait, I think I know what they did there.
factor ax out of the denominator.
Oh, now I see what they did there.
The whole fraction.
Oh wait, I think I figured out what they did there. AC. I think I see what they did there.
They divided everything by x squared.
Yep. Let's give it that x, turn that x squared into 1.
Yeah, no, I think that's right.
You can divide the denominator.
I guess I don't know,
Look,
but that's what they did. It looks like.
look, I'm just trying to put the pieces together. What
Yeah.
I'm given.
No, you're doing good.
But this is the only thing logical enough to result in this. Which is in at which.
I don't know why. I like this.
Wait, one of my x
It
results in
feels
0, right?
unnecessary.
No.
Okay, and then they somehow no, they didn't. They couldn't have divided it by x squared. Just like they have to get rid of this too, so they have to pull out an x and then just divide by x. I think.
Which results in this.
Yeah, so they pull out an x and then they just divide by x. They don't divide by x squared. Because you have to get rid of the x on top. Okay.
What do you mean pull out the x?
In the denominator?
Like this?
Yeah. And then they
Wait a
divide
minute.
by x after that.
Wait a minute, didn't our structure taught us this before?
So that these x's can cancel.
Wait a minute, didn't our structure taught us this before?
I have no idea.
Yeah, I think
I'm pretty sure she did.
Madeline went over this.
I wouldn't be surprised.
I'm pretty sure she did.
Sorry. This is yours.
Yeah, sorry, yeah, you're good.
I don't know. This is a really hard one.
Yeah, this one's just a lot of like head stuff.
Yeah, that's the answer that was on the thing. You have to divide by x on the denominator though.
Oh wait, now I. No wait, now I. See. Oh wait, now I see what happened.
Bless you.
Thanks.
I think I see what happened. Wait. Oh, I think. Oh, wait. No, that doesn't make any sense. Okay, that part didn't make any sense. Okay, what I just did didn't make any sense at that point.
I think we just have to plug in infinity again. And then we get. Oh, that's why they did it, so that when you can plug in infinity, it doesn't completely kill the equation. So, like.
Basically,
Okay,
having to go
so.
into a fiery inferno.
Yeah, so they do the root of 1 plus a over x. What is it, minus or plus?
It was a plus.
Okay, plus 1 plus b over x. And so when you plug in infinity, this is going to reduce to 0, so it's just going to be root 1 plus root 1, which is just 1 and 1. It's going to be a minus b over 2. Whatever a and b are. What are a and b?
Mm-hmm.
What are a and b?
Hmm.
Yeah, there's an x there.
Actually, the question itself didn't ask.
A and b are like constants, right?
Yeah, the most likely constants. Most likely not the constant. So don't mess with them.
Okay, so a minus b over 2.
Mm-hmm.
Okay. Well, that was really convoluted, but we got there.
Yeah.
Okay.
Hopefully number 63 is more straightforward.
Yeah.
Hopefully. Next we will do problems 63 of the applied problems for 2.6. I should probably flip these. Apply is asking find the limit as t approaches to infinity, and then use ugly v of t Guys, tell me if I'm doing this. Verify if I did this right. Like, I'm pretty sure there's. No, wait. Wait, there's something that doesn't matter. So just verify if I'm doing this right.
I'll let you know.
Thank you.
It's 2.6.
Okay. First up, who's done this song before? You got if not,
Did we do this in class? No, we did 62 in class.
Yeah.
yeah, this is 63.
I think I might have done this one, but we'll see. No, I did not do this one. Under certain assumptions that the velocity of t is a falling raindrop.
Okay,
So we're calculating the velocity of a falling raindrop at a given time.
okay. First up,
G is the acceleration
first
of
thing
gravity.
there's, well, I done the equation. Because, why not? Because, I don't know. Who doesn't do that? Since, that's very important.
Presumably, A is just going to be the terminal velocity of the raindrop. So we'll see if you get that.
You can go next.
Okay.
Or you can use my iPad to see your thing.
As team approaches infinity.
And you can write bigger if you need to.
So you need to find V of infinity.
Mm-hmm. Just to verify, this looks right. Does this look right? Just need to verify.
Sorry, it's a little hard to read, but like, so when we do V of t, t is infinity, then you do 1 minus e to the g times infinity divided by that, so it's just going to be e to the infinity.
Which is 0.
Is that 0?
Which is 0 at that point, right?
Well, isn't e just a constant? Well, it's like a special number or whatever, but it's positive. But it's multiplied by negative, so it's negative infinity maybe? I don't want to say it's 0. That would be kind of weird. Maybe it is.
Mm. That's what I'm hoping to be my. Just be confused on that. The next part I say is the graph.
It would make sense if it was 0 actually, because if it's 1 minus 0, then it's v star times 1, which is just v star, and that's like the answer that I think we should be getting. But
we just need something to verify it. That's where this comes
so it's
in.
e minus g times infinity divided by v divided by terminal velocity. Okay, so what's e to the infinity? E to the negative infinity, I guess.
And you ask for part B, I grab the thing, like literally grab the thing.
I think anything to the negative infinity is probably 0, but let me check.
Yeah, anything.
So I'll just do 5 to the negative, and then I'll just make it an extremely large number. It's probably going to be really close to 0.
Essentially, the graphics look like this when I put it in.
Yeah, no, that makes sense.
I mean, when I did B,
Bruh.
the graph looked like this.
Yeah. And what did you plug into Desmos to get that? Did you just plug in the equation?
Yeah.
Okay.
Yeah, I did.
Okay. Yeah, that makes sense.
So, I need to make sure I did all this right. For the love of God.
Okay, yes, it is 0.
Yeah.
So,
Yeah, so the graph speaks to itself.
right, so A, it approaches terminal velocity as t approaches infinity. And then graph Vt if V star equals 1 meter per second. How long does it take for the velocity of the raindrop to reach 99% of its probably terminal velocity? How long does it take? Christian, did you get B?
I mean, this.
No, B, it's asking you how long does it take for the raindrop to reach 99% of its terminal velocity.
Oh, you did get that. You got time equals 47 seconds, I think. That's what you wrote down in your work.
47 seconds? Okay, and then you calculated that just by plugging in
Yeah, pretty much.
V star and G, and then you just solve for T.
Yeah, pretty much.
Okay. Actually, no, you have to set V of T equal to basically V star and then solve for T. Or 99% of it, I guess.
Yeah.
0.99
Yep, already done that.
V. Gotcha.
Times. I mean, I need to make sure. It's important to double check these things. Otherwise, you might get something that doesn't look right.
Is there anything else you need to discuss on this one?
No, I think that all made sense.
At this point, it would take. Yeah, when I plug it in, I got 0.699 seconds. 0.469 seconds if I put it up. So I did one calculation error.
So how many seconds does it take?
0.470 seconds.
I don't believe that.
Yeah, neither did I.
Because if you think about it, it's not going to take a raindrop to go from no speed to terminal velocity in half a second, you know?
Yeah. So I might have done something wrong somewhere.
Well, let's see how you calculated it.
Yeah, just show us your work for that really quick.
You got to take the original equation and then plug in all the variables that you're given.
Okay. What's up? And I'm maybe help calculating the thing.
That's okay. Yeah, I can. I have a calculator up if you need help. Shoulders really thin.
Oh, why? The puzzle I am confused about is that T over there.
What about the T?
No matter how many times I look at this, it still kind of confuses me. Like, what does it mean?
The
The
T
T
is
is
the time.
Yeah. So as the raindrop is falling down, it's how long the raindrop has been falling. And then V of T is obviously the
The
velocity
at the moment.
at that moment. Yeah. So is it going to be V of 99? I don't think it's going to be V of 99. Because that's V of 99 is saying it's going to be that's the velocity after 99 seconds, but we're not interested in
Yeah.
we don't know the time yet. So what we're doing is we're
calculating for time.
right. So we're going to set V of T. It's just going to be equal to 0.99 V star. So 0.99 V star equals, because see that V star is our terminal velocity, and it's asking us
Which is one of the.
what's our time when our velocity is 99%
Okay, so
of the terminal velocity,
0.99 times 1,
not times the one.
or
It's just V star. It's 99% of our terminal velocity is equal to, and then our equation.
which is just putting all the variables at that point.
Right, so it's going to be V star again times 1 times E to the minus, and then it's like 9.8? 9.8 times T. T is the variable we're interested in, divided by V star again. Do we know our terminal velocity? Did we just figure that out? I don't remember. Hold on. No, we just said as it approaches infinity. So, didn't. Oh no, it's 1 meter per second. Okay, so anytime it says V star.
Yes,
Yeah, 1. Okay, that's why you did 1 earlier.
yeah. 1 meter per second.
Yep.
It doesn't matter how many times you slice it. V star is 1.
Yeah.
That means
So
this
it's
is.
0.99. Yeah.
That's why you times this part by 1.
Yeah.
Yep. And then we just solve for T.
Mm-hmm.
Okay, so if you need me to calculate something, let me
Yeah,
know.
I definitely need something to calculate this.
Okay, so you have. I can't read.
That looks like 111. So is that like a parenthesis? It's. No, it's 1 parenthesis 1 times E.
1
Yeah.
parenthesis 1 times E. Okay.
Yeah, yeah.
Yeah.
So then
So it's just 1 times E.
Sorry for that confusion with that parenthesis.
you're good. Let me get Desmos up.
Oh god, yeah, I don't even know how to like algebraically. This is kind of hard.
So it would be 1 times E.
It's been 9.8 T divided by 1.
The thing is, we're trying to solve for T.
Oh my gosh, Desmos on your phone does not work. Okay, so 9 times 8T, 9 times 8T, divided by 1.
Actually, it doesn't matter. Actually,
Oh.
this stays the same.
What stays the same? Well, yeah, because it's just times 1.
Mm-hmm. But for this part,
It's not letting me put 9 times 8t.
we need to isolate t on the other side and then solve, but like I don't even know how to get t out of there. Like, do you know how to get an exponent out?
9.8.
You know,
Isn't it
out an
natural
exponent?
log?
It's like natural. Probably, I wouldn't be surprised. But I just don't remember that. This seems kind of like either a guess and check problem or a Wolfram calculator problem.
Okay, 9.8.
Equals 0.99.
Yeah, that's what I got. If when t is equal to 1. Yeah, that's what I got with t is equal to 1.
You said the exponent on e is 9.18? Or
9.8 t divided by 1.
Okay.
So yeah,
9.8.
9.8 t.
You said 18.
18 seconds.
No, 9.8
8t. Oh,
instead
okay.
of 9.8 t.
Yeah, 9.8 t.
Oh,
No,
wait.
It's not solving it.
Ah. So that's what I
It's
forgot.
Oh.
that. That's what it is. Whatever that equals is what t is. I mean, do we really need to worry about simplifying this, or?
No, I think it's fine. I don't think we need to
Yeah.
simplify.
Wait, do
Alright.
we need the.
No, it's just that.
What do we do with
Whatever
the.
that equals.
Wait, what do we do with the 9.99?
You just leave it there.
Maybe. Maybe.
I mean,
we can
if you're trying to solve for t, then you have to manipulate the whole thing and blah blah blah.
Okay. We'll move on to the next question then. Is that okay, Christian?
Yeah.
Okay.
It does. Yeah, I did everything I can.
It looks good.
Cassandra, 2.6, play problem number 3. It asks for your limits at infinity, negative infinity, 1, and 3. The limits are easy because over here it's just leveling off at like, what is this, 2?
-2.
Yeah, negative 2. And then negative infinity is,
Leveling off at 2. Okay.
I didn't draw the graph completely right.
No, you're good.
And then for 1, it's negative infinity.
That sounds about right.
And then 3 is,
You already did 3. I think you.
I did?
Yeah.
Okay. That's not what I was confused on. My question was on the asymptotes.
Okay.
Because there's one here, 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 and there.
Mhm.
But for the horizontal ones, there's one at like, what is this? Why did I write 2 there? 2.
Yeah.
And at negative 2.
Yeah.
But it's not like all the way across. Because it's, but it stops here because there's one there, right?
Wait, what's the
There's-
question though?
The question is asking about the asymptotes, and she's wondering if because the asymptotes intersect, are they not continuous across the whole graph?
Like, is that possible to have a discontinuous asymptote?
Are you talking? This is number 3 on 2.6.
Uh-huh.
Okay, and then a discontinuous asymptote.
Well, because see how the graph shows it going above the asymptote line at +2.
Yeah.
At +2.
Do you see how it goes above the asymptote line? So is there no asymptote
No, I don't see
there?
how it goes
Well,
above the
see
asymptote
where
line.
she's pointing.
Okay.
See how that right there. Like if you follow the line of the graph with your finger, there's the asymptote right there, right? And if you follow the graph, it dips down, but then it goes above the asymptote right here,
To the vertical one.
right?
I still don't know what you're talking about.
Well, like, okay, so if the asymptote goes along right here, all the way across the graph, right?
No.
No, it doesn't go all the way across the graph?
Not really sure what you mean. By going, what do you mean goes across the
So we're saying there's a horizontal asymptote along 2 right here.
Well, no, there's just a horizontal asymptote, like, going that way.
To the left?
To the left.
Only to the left.
Yeah.
Okay.
That's what I'm asking. Like, how do I...
How do you what?
How do you write an asymptote only to the left?
Algebraically, or...
Because it'd be y
Yeah,
equals 2,
When
but
it
that's
asks
for, like,
when it asks you
all-
to define the asymptote, you write y equals 2. But if it's only to the left, you say y equals 2 approaching from the left.
I think that you can just give... I think you just say y equals 2. I think that, like... I think you can just say there's an asymptote at y equals 2, yeah.
Okay, so it doesn't matter that.
I don't think it matters. I don't think there's going to be any interference or anything like that. Like you can say there's a negative, you know what I mean, horizontal asymptote of y equals 2, but there's also, there's like 2 other points at y equals 2 as well.
Yeah.
But if it's asking you the y coordinate of the horizontal asymptote, one of them is going to be 2. The other one is going to be like -2, right?
Yeah.
But yeah, you can have multiple x values for a y value on the graph.
Okay. But it's fine that the asymptote at -2 and 2, it has a line that crosses that asymptote.
Yeah, I think it's fine.
Okay. That line crossing the asymptote at those points is fine.
Because like there's an asymptote at y equals 2, but that doesn't mean that like y equals 2 is now under jurisdiction of the asymptote. You know what I mean? Like
Yeah, I guess so. Yeah. Okay. I just always thought asymptotes went all the way across the graph.
Right. No, I don't think so.
Okay.
I guess that was only basic algebra,
Yeah.
and then this is like...
I might be wrong.
Yeah, or maybe, if we are wrong, then there's only vertical asymptotes. There's no horizontal asymptotes on this graph.
I think there are definitely horizontal asymptotes, though. Almost assuredly, so.
That's what I'm saying, is if the line crossing it, I don't know.
Matters? I don't think it matters. We'll see, though. Yes. I don't know.
Okay. Cool.
Okay.
I did number 44 of 2.5, and this is a f of a function of r, where g is gravity, m is mass, r is the radius. Those are all constants. The lowercase r is the variable, and the question is f a continuous function of r? And for r, lowercase r greater than uppercase r,
Mm-hmm.
I would say yes, because lowercase r is not in the denominator, so you can't have like 0 over 0.
Yeah.
So no worries about any holes or asymptotes. But for lowercase r, did I?
Oh, okay, yeah. Okay,
That's
that
fine.
makes more sense, yeah.
And then for lowercase r greater than or equal to uppercase r, the variable is in the denominator, so I say it would not be continuous there.
Mm-hmm.
And I'm wondering,
Because it can be undefined, or
yeah, because you could have 0. R equals 0.
Yeah. Yeah, no, that makes sense. But then also R is included in everything because there's everything less than big
So-
R and everything more than big R, including that point.
okay, yeah. So if you just think about it conceptually, if your distance from the center of the planet is 0, then what? There's just no gravitational pull whatsoever, but it's like undefined rather than 0.
Yes.
Does that make sense? Because like we don't understand gravity or something like that, so
Yeah,
it's undefined.
Because gravity only really affects you when you're
away from
Away from
in
it,
a
right? But if
certain
you're
range.
at the center of it, then
It just doesn't affect you.
right. But then you would think, oh, well, then it's 0, but it would be undefined if it was in this equation.
That seems like an astrophysics question, not a
Yeah,
calculus question.
I'm just thinking about it.
Yeah.
But
Makes sense, though.
Does that make sense? Like only this half is discontinuous?
Yeah, no, that makes sense.
Okay.
Okay, yeah.
Is that your only question?
Yeah.
Awesome.
Wait, but what if big R is 0?
Big R is a constant. It's the radius of Earth.
So
Oops.
it can't,
Okay, never mind.
unless the radius of
guess
Earth
if
becomes 0, and then
greater
we've
is-
got more problems going on.
I guess if greater than R, you're off Earth's surface
Mm-hmm.
or on it. And then this one is if you're
In
underground.
Earth's surface, yeah.
That would be
Except at the point when you're at 0.
Oh, but it says if R is greater than, if small r is greater than or equal to R, then that bottom equation applies, right?
Yeah.
But R is a constant. That means small r can't be 0.
No, big R is a constant.
Big R is a constant, that's what I mean. Small r can't be 0. So given the constraints, I think they're both continuous. But if there are no constraints, then they're not continuous.
What do you
So-
mean by restraints?
So
By,
the
like, this
so
stuff?
the bottom equation applies only given small r is bigger than big R. But if that constraint isn't there, then there's a possibility for R to be equal to 0, in which case
yeah,
it's continuous.
yeah. He's right, because
Yeah.
if it's a constant radius, then it has to be bigger than that, so it wouldn't be 0. So it's continuous all over the graph.
All over? Okay.
Given the constraints, yeah.
Makes sense.
Does that make sense?
Yeah.
Okay.
So the 0.
Yes. I watch a couple Neil deGrasse Tyson videos. Hello, this is Dylan for Team 1. I'm doing number 41 on section 2.6. This is my play problem. And we have to find the horizontal and vertical asymptotes at the curves of this equation here. Now I'm unsure how to do that.
Okay, well, the rules for horizontal asymptotes are like the powers of the numerator and denominator. But since the powers are the same in the numerator and denominator, there's no horizontal.
There's no horizontal.
So don't worry about that.
So if it's like greater up here, or like how would that work exactly?
I think I don't quite remember, but I know if one is greater than the other, then you're gonna have like,
So this is like x squared, then I would have one like on the right side or the left side or something.
sure.
Sure.
I just know if they're the same,
Then
don't
there's
worry
none.
about asymptotes.
Yeah,
Okay.
and you could always just graph it to find your asymptotes.
Got it. Okay, and then what about vertical?
Vertical is like, you remember if you factor that and get x minus 2 as a factor in the numerator, that's your vertical asymptote.
Got it. So if I factor, wait, I can't really factor that 2x plus 1. Is that really factorable?
If the
Wait,
degree of a numerator is less than the degree of the denominator, then there's a horizontal asymptote at
So if
0.
this were x squared, then this would be a horizontal asymptote.
Yeah,
Do you know where it would be?
at 0.
It would be at 0. Okay.
I knew there were rules.
If the degree of the numerator is greater than the degree of the denominator by 1, there is no horizontal asymptote or a slant asymptote. I don't know. I'm just reading rules off the internet. But
Okay.
for vertical asymptotes of a rational function may be found by examining the factors of the denominator that are not common in the factors of the numerator.
But we're supposed to be able to do this algebraically.
Yeah.
So
So if the x minus 2, that's not a factor.
If x equals 2,
Numerator.
what if x equals 2?
Or x minus 2.
Does that just mean it's undefined, or there's an asymptote?
Well, if x is 2, that'd be zeros.
So what if x approaches infinity?
You can't have it in asymptote at infinity.
A horizontal asymptote? What if I said y equal to
Why
infinity?
do you want an asymptote?
I don't know. I'm just trying to like figure it out. I don't really know what to do.
We have 2x plus 1.
Like I could just graph it, but you're supposed to be able to do it algebraically.
Yeah, that's what I'm
I
trying
don't
to
even
figure.
remember doing this though. Maybe we did. Did we? We did 15, 29, and 31. No, we didn't do these. Use theorem 5
That must have been on our
flashcards.
Yeah. Does anybody have their flashcards with them?
I have like a file on my computer. Set 3, I think. Where are they?
It says there's a vertical asymptote at 2 and horizontal asymptote at 2.
Nice.
So you can find the horizontal asymptotes by comparing the degrees of the numerator and denominator.
Well, let's figure out exactly how to calculate that.
Yeah.
Okay, I think it's set 3. Okay, I have a PDF here. Theorem 5.
Finding horizontal asymptotes and
Let f be defined on both sides of a, except possibly at itself. Then, the limit of x approaches a of f equals negative infinity means that the values of x can be made arbitrarily negatively large by 1. Doesn't really help. This is really annoying. Alright. Alright, Solcon. My boy can help me out.
Are they all 1 too?
I'll just pause the video.
Yeah.
Okay. Alright, we're back. I had to do some research, but figured it out. So to find the horizontal asymptote, all you have to do is we have to compare the exponents on our leading coefficients here. Or not leading coefficients, but the x's, whatever the word is.
Greatest degree.
Greatest degree, right. Okay. And so if the exponent in the numerator is greater than the one in the denominator, there's no horizontal asymptote. If the one on the denominator is bigger than the one on the numerator, then there is. And if they're equal, which is this case, then the horizontal asymptote is going to be the ratio of the coefficients of the leading x's. So in this case, it's going to be 2 over 1 because this is 1 and this is 2. It's going to be the ratio, and then our horizontal asymptote is going to be a 2. And then for our vertical asymptote, all we have to do is set the denominator equal to 0. And then it's just x equals 2. So we have a horizontal asymptote of 2 and a vertical asymptote of 2.
Is that because if the denominator is 0, then it's undefined? Is that why you set it to 0?
I guess so. That's just what I said in the video, but I'm not entirely sure.
Okay.
But that makes sense.
Sounds good.
Alright, so this is the apply problem. It's number 50 on 2.8. And we have to take this position function, and then we have to graph the velocity, acceleration, and jerk functions just by looking at it. And then we have to calculate roughly what jerk would be when position is 10. Or when acceleration is 10 or something like that. After 10 seconds, when t is 10. This is time. Okay, cool. So just like looking at it, you have to just sort of make this velocity. So I'm just graphing these out. Acceleration. And jerk. So we're just doing the derivative of every one. Okay, so the rate of change is sort of like increasing here. So we're going to start at 0. It's going to be increasing. I'll label this like 20, 30, 40, just so we have like a reference. Okay, so it goes up to 10, it's just increasing, and then, this is actually important for later, I need to move this 10 a little bit, so like, kind of where it reaches its peak, because that's what it does on the computer, it's not perfect translation. Okay, so it reaches its peak velocity at 10 seconds, and then it starts to round off, and then decrease, and then it's sort of like it stays the same at a certain point. So I just want to say that it sort of like flattens out. And then the acceleration would just be that. Can the computer see my acceleration graph?
Yes, it can.
And then this is just like that. And so the acceleration graph is going to look relatively similar in the beginning. It's going to keep going up, and then at 10 it sort of actually zeroes out. Never mind. Okay, so here we go. So it's going to go up and up and up, and then it just like drops, and then it goes down like to the negatives, and then it's gonna go back, and then it's just gonna like
Even
to
out
zero.
at 0.
Yeah, it's gonna even out to 0. And then jerk. Let's see. So we're looking at this here. It's going up and up and up, and then at like 5 seconds it goes to 0 or something. So it goes up and then down, and then it's very, very negative, and then it goes. It's just like the same thing almost. And it goes back up. Wait a minute. Okay, it's going up, and then at roughly 5 seconds, it goes to 0, and then it goes extremely negative, and then it goes back up to 0 again at like 15 or something, and then it's positive again. Yeah, so it's positive, and then it's going to go down to 0. Okay, and then so that's what all of them like roughly look like. And then the other question was, at 10 seconds, what is jerk going to be? And that's the reason I was like kind of worrying about all this labeling stuff. This isn't a perfect translation, but 10 on the actual graph is about here, which is 0. So jerk should be about 0 at 10 seconds.
That all makes sense.
Or wait a minute.
Oh.
It does something wrong.
Well, the derivative of jerk at 10 seconds is 0, not jerk itself. But I just don't know if that's a translation error on my part. What? Because in this it would be like negative something, right? But
Yeah.
I just don't think it is.
But
I
it's
think I just
flattening
drew it
out,
wrong.
so it's it's flattening out
Okay.
at that point.
Yeah, in the actual graph at 10 seconds, 10 is right here. I just messed up.
Okay.
So
Okay.
you scaled it wrong. Everything's over
A little
a
bit.
bit.
Yeah.
Yeah, it's just the fact that I don't have like
A perfect graph.
well the yeah like
The
like
perfect
every
grid.
the grid is like all messed up, and so it's hard to like.
So the shapes are good. It's just
Yeah.
The shapes are good, yeah.
It's just the grid would be off
The grid
by
is
a little
off.
bit.
Cool.
Okay.
Any questions?
No, not really.
Okay. Good work.
You know how I did that, and you could do it yourself.
Yeah, you just found the
Mhm.
derivative of each one, right?
Yeah. Okay. Cool.